So we just talked about domain. We are also going to be working on describing the domain of a function. So a domain or a function can be either increasing over a certain domain, decreasing over a certain domain, or constant over that domain. So what we're going to do is look at a few examples of this. Once this clicks, it's just very easy, but it can take a while before it clicks. So here's a function. We have our friendly parabola, and you'll notice that our y values over a certain domain, our y values decrease. They get smaller from left to right. And then they kind of reach this turning point, and then they start increasing from left to right. Remember, we read functions from left to right, just like we read English or Spanish. So our function is increasing from 0 on to infinity. I didn't mean for it to do that, right? Our function is going up. Our y values are getting bigger. So where we would say our function is increasing is from 0 to infinity. And our function is decreasing, meaning our y values are getting smaller from left to right, from negative infinity to 0. Right? They get smaller, 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 smaller. At 0, they kind of stop decreasing and they start increasing. And if you're wondering, wait, why is this an open interval, meaning that we're not putting a bracket there? One way to think about it is that a function is increasing if the point to the right of it is higher than the point to the left of it. Well, our function doesn't increase at 0 because that's the lowest point. That's actually a minimum. Okay. So let's get rid of this and get rid of this. Let's look at another function where we might have a constant. Ooh, okay. So let's say our function starts going like this, and then from here to here it's flat, and then maybe it starts to increase up to there, and then it takes a steep turn and it starts decreasing. Now, you may be like, wait, what is the equation for this? This is weird looking. Well, it's a piecewise function, meaning that there are different pieces of this function, 1, 2, 3, and 4, and we'll look at each piece separately. So let's look at where our function is increasing. So increasing means that our y values are getting larger as we travel from left to right. So here, that looks like it's increasing on that interval. Now, when we describe the interval, we describe only the domain. So it looks like it's increasing from 0 to, what is this, 4. So our function is increasing from 0 to 4. Now, I notice that my function is decreasing. It's decreasing here and also here. Ooh, it's decreasing in 2 different areas. So when I describe my decreasing intervals, I would say it's decreasing from negative infinity till we get to negative 6. And then it stops decreasing from negative 6 to 0. It's actually constant. Then it increases. The values get bigger, and then it takes this steep turn and it starts decreasing. So it starts decreasing again. So I'm going to describe that decreasing again. I'm going to say it's decreasing from 5 on to infinity. From 5 to infinity, I'm sorry, not 5, 4. 4 to infinity, it decreases. As x starting at 4 and then moving on till forever, it's decreasing. Now, just a little information about this kind of notation. If you want to say it's decreasing over this interval and this interval, you put a U in between. That represents union. So here and here. Okay? And then where is it constant? It's constant, meaning it's flat. It has a slope of 0. It's flat from -6 to 0. And you'll notice that the domain of the entire function is all real numbers, or it goes from -infinity to infinity. And that -infinity to infinity is included in our entire portion. So let me just color code this for us. So we are decreasing from -infinity to 6, then -6. Then from 6 to 0, we are constant. Then we start increasing from 0 to 4. Then we start decreasing again from 4 to -infinity. So our entire domain is included in all of these intervals.